Hello friends, welcome. Friends, we all know that BSNL is in the process of stabilizing their 4G services and they still have to deploy a lot of 4G towers in order to increase the coverage of their 4G network. Now, Minister has been saying from the beginning that whatever equipment BSNL has deployed for 4G is upgradable to 5G. And therefore, BSNL will have no problems. And therefore, when they move towards 5G, it will be a seamless upgrade. And once their 4G network is stabilized, they are going to move towards 5G. And the consumers who are hooked onto their network will be able to experience 5G service. And that's the BSNL. That is what BSNL plan is, and all these articles that you see right in front of you points in that direction. Now friends, why I am doing this video today? I am doing this video to explain to you the options that BSNL has to move towards a total 5G network or deploy a meaningful 5G network which can serve consumers' interest, right? Both in terms of coverage as well as in terms of quality, which means capacity. So we'll go option by option, evaluate what options BSNL has, and that is going to give you a flavor whether BSNL really has got the capability to deploy 5G or not, and whether those equipment BSNL has deployed, which are 5G upgradable, can be used in future to have a full-fledged 5G network for BSNL or not, or this equipment is only going to be used for 4G till they reach an end of life. That's the whole purpose of this discussion. So let's go step by step. So first, let's look at BSNL spectrum pyramid in order to get an understanding that what spectrum bands BSNL has. That is going to tell us that what option BSNL will have to deploy 5G and what constraint and inflexibility or difficulty that BSNL will face. The first band is the 3500 MHz band. It's a plain and virgin band. No problems here. BSNL can deploy 5G without any problem. Then we have the 2500 MHz band. BSNL is going to deploy 4G here because they won't be doing two TDD bands for 5G. Makes no sense, right? So this is time division multiplexing band, means they have got only block of spectrum and they are doing time division to send data up and down, right? Now we have got the 2100 MHz spectrum where they have bifurcated into two different compartments. One compartment is for 3G here, which is this color, and the other compartment is for 4G, 4G and 5.5 for 3G. And the 700 is thereby using 10 MHz for 4G and 900 is they are using for GSM. So now let's go step by step. In order for BSNL to deploy for 5G, they can't just rely on the 3500 MHz spectrum because 3500 MHz spectrum does not have reach, right? So they need a low frequency band. So they have to choose between 900, 700 and 2100 because I told you that 2500 MHz is ruled out, right? So we'll go step by step. Can BSNL deploy 5G in 900 MHz band? And if they have to do so, what kind of problems that they are going to encounter? So this is the slide deck I have to evaluate why BSNL can't deploy 5G in 900 MHz spectrum and what kind of problems they will encounter. First, the 900 MHz spectrum is 6.2 MHz of width. Now, typically 3GPP defines 5G in chunks of 5 MHz. You can do non-standard deployment also, but it is in chunk of 5 MHz. That is 5 MHz, 10 MHz, 15 MHz and 20 MHz because these are commercial equipment which are available. Handsets are available in these chunks. So if BSNL is going to use 6.2 MHz of their spectrum and deploy 5 MHz carrier width of 5G, they are going to lose 1.2 MHz of spectrum, which is 20% loss immediately. And then because 5G needs certain guard band on both sides of their spectrum band, their usable spectrum will be 4.5 MHz. Now 4.5 MHz is a complete loss of, or you can say complete waste of 900 MHz because currently 900 is used for GSM. They will neither be able to serve their GSM subscribers nor they will be able to serve their 5G subscriber because for 5G you require a new handset. So you have to get rid of your value customers completely. Those customers who really can't afford 5G phone, they have to be knocked off from their network and you have to bring in a new device, a new customer who can afford those devices, and he is not going to get any service because this 4.5 megahertz spectrum is grossly insufficient, and therefore 900 megahertz band is completely ruled out. You can't. Now let's evaluate whether BSNL can reform their 700 megahertz spectrum to 5G and what kind of problems that they are going to encounter during the refarming. Now, normally 700 megahertz spectrum, right? If it was virgin, you could have deployed for 5G without any problem. Now, the problem with BSNL is that 700 megahertz spectrum is used by 4G. So you can't deploy, you can't uproot those base stations because you need to serve those customers who have 4G phone also. Because there could be some customers who may not have those high-end devices which can support both 5G and 4G in 700 megahertz band. Some devices may not have the capability to do 5G in 700. So you need to serve those devices who are only 4G capable. So you can do it theoretically using a technology called dynamic spectrum sharing, which Bharti is also using in some of the areas. Today, I am going to explain to you that why dynamic spectrum sharing in 700 megahertz is going to be a completely useless solution. And you will understand why. And for that, I am going to take you through this animation. Right? So let me just run this animation from the beginning so that you understand what is going on. So this is BSNL current network. What is it? 700 megahertz 10, 2100 megahertz 10, 2500 megahertz 20, 3500 megahertz 70. So these are all LTE, right? This color is for LTE and this is for 5G. Okay, it's very simple. No issue. So you see that LTE, 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 NR, right? BSNL's current network. Now let's go forward. So what BSNL can do? BSNL can deploy 5G in 2100 megahertz spectrum LTE and DSS in 700 megahertz band, right? So this option BSNL has. So 2100 and 700. But before 2100, 700, they will go step by step. First, what they will do? They will deploy 5G in 700 megahertz spectrum. And they have to share that capacity with LTE also. And how they are going to share it, I'm going to explain to you later. But while they do that, there will be a capacity loss of 25%. So what I basically mean here is that if this band was purely used for 4G, they would have got the full 10 megahertz of capacity. Now, if you share this spectrum between 5G and 4G, then instead of 10 megahertz, now you are using for this spectrum only for how much? 7.5. So you have reduced your 10 megahertz of spectrum to 7.5 only. So there is a direct loss of 25%. And why there is a direct loss of 25%? We will discuss as we move forward in this presentation, which means that if 700 becomes 5G and you let the 2100 megahertz remain LTE and 2500 megahertz remain LTE, then you have got an anchor carrier of 700 megahertz, which is how much? 7.5 divided by 2, right? So this is 3.25. 3.25 megahertz of spectrum capacity anchored with 3500 megahertz spectrum. That's all you have. It is worse than the 900 megahertz band where you have at least 4.5. The other problem would be that if you are doing voice in LTE and you abandon your 900 megahertz GSM, then those people who are relying on voice in LTE, which will be more stable than VoNR, is going to face a severe capacity problem because everybody has to move towards VoLTE because VoNR may not be stable. So your voice capacity is going to become so low because now from 10 megahertz, what you have done, you have reduced it to 3.25 megahertz only. And that is going to screw up your voice experience and you will continue with your GSM network to rely on voice. Your voice quality will be worse because of this loss of overhead. So you can't do DSS to share 700 megahertz spectrum, right? Then you can do 2100 megahertz spectrum to convert the 2100 megahertz spectrum to NR. That option you have. Now 2100 megahertz spectrum is a high frequency spectrum. If you convert the 2100 megahertz spectrum to NR, you still will have the voice problem because for voice, you have to rely on the 700 megahertz spectrum because you can't use 2100 megahertz for voice. there will be huge coverage holes and people will not get very good quality voice. We have already seen it, and therefore Reliance, when they started deploying 4G, they had 1800 megahertz spectrum, but they waited for the 700 megahertz to come, before they started rolling out services. They did not do it when they had 1800 megahertz spectrum, right? So it is completely useless to have 2100 megahertz spectrum being consumed for LTE and rely on this for doing voice, because 700 is going to be very, very low, and the LTE 3.25 is grossly insufficient for you to do voice, right? So which is why there is a problem. Now we will talk about this overhead loss of 25%. Why there is an overhead loss when we do DSS, dynamic spectrum sharing, and this is going to be pretty interesting, friends, because this is an animation which I have created, which took me a lot of time. And those who are technical, they will also benefit, and those who are non-technical will benefit, because I am going to make it very simple. Okay, so let me run this animation first, right? Okay, so I stop here. So this looks like a very complex structure. Don't worry, this is a very simple structure. Let me explain to you. This is frequency and this is time. Just be with me step by step. Don't worry about this heading. Forget about it, as if that it did not exist. So we have got a matrix here with frequency on this side and time on this side, right? And what is this grid all about? Because this grid, these frequency blocks that you see are separated by 15 kilohertz. Means these are of width 15 kilohertz. So it is as if that you have got a bandwidth of 10 megahertz, which are broken down into 15 kilohertz. Okay? Simple, right? And this 15 kilohertz of bandwidth is acting like a pipe where this information is getting transmitted. You see? And this is time. So you have, as if that you have a bandwidth of 15 kilohertz where you are running time division multiplexing, right? So you have got a symbol of a particular size, which is how much? Which is going to be 1 upon this bandwidth. And why this is 1 upon bandwidth, we will discuss later when we have time, because this is not for everybody. Just assume that this time duration is 1 upon f. Means 15 kilohertz is the overall bandwidth. 1 upon 15 kilohertz is going to be the duration of this time, right? So all this grid that you see, it's harmonious. Every symbol, this is basically carrying a symbol, right? So this bandwidth, 10 megahertz divided into 15 kilohertz each, and you are running like a train, which is like goods train, with each and every compartment of the, or you can say bogie of the goods train carrying information. And this goods train bogie is of a size 1 upon f. That's all, right, friends? So this is called symbols running over, the physical carriers which are separated out by 15 kilohertz. And why we do that? Because if we had a uniform bandwidth, it becomes very difficult to design filters. So therefore, we break it into small chunks and make those chunks orthogonal to each other so they don't interfere with each other. That's the reason. So this is an OFDMA grid f of LTE of a subcarrier size of 15 kilohertz. Now let's move forward here. Right. Now, if you run NR, then what happens is that in case of NR, in 700 megahertz, you have an option to do a subcarrier size which is greater than 15 kilohertz, means double. You can do 60 kilohertz also. So why do you need a subcarrier size of 30 kilohertz or a higher subcarrier size in case of NR, and what advantage that it delivers? It's very important to understand this, because in LTE you had got a subcarrier size of 15 kilohertz, means breaking the 10 megahertz of bandwidth in smaller size of 15 kilohertz, and the width of those symbols which are being carried as if that it is a goods train with different compartments which is being loaded with symbols is the size 1 upon f. That is the subcarrier 15 kilohertz divided 1 divided by 15 kilohertz. Now it is going to become 1 divided by how much? 30 kilohertz, which is going to be half of that LTE, which means that your symbol duration is going to become low. It's going to become half. Means your data speeds are going to increase. And that's why we are using 30 kilohertz of subcarrier in order to increase data speed. And LT will have a lower data speed with 15 kilohertz subcarrier. NR can have a higher data speeds, or symbol duration decreases, then you can transmit more information because this is time division multiplexing. Do you understand now? That's why the subcarrier spacing has increased, right? So fewer wider subcarrier, shorter symbol duration, right? Simple, right? Now let's move forward. Now 60 kilohertz, same situation. This becomes 60, this becomes 3 times, and this becomes 1/3. That's all. One fourth. Because this is not 3 times, this is going to be 4 times, and this is going to be 1/4, right? Simple. Now let's move forward. Now we have DSS. Now in case of DSS, what happens is, friends, that both NR and LT sharing this common grid, right? Why? Because when you are running DSS, this 700 megahertz 4G, which already exists, you can't abandon 4G. You have to run 4G along with 5G, because those 4G subscribers will be able to have the services live. Otherwise, they will be knocked off from the equipment or from the network. And therefore, you need the subcarrier of 15 kilohertz, stable and fixed, so that LT can run and the control signals overhead can run. And therefore, NR does not have the capability to reduce the subcarrier, increase the subcarrier spacing and reduce the symbol duration. Because if you increase the subcarrier spacing, which we already saw, the symbol duration is going to reduce, and therefore you will be able to increase the data speed and you will have more flexibility to carry more data, right? But you can't do that in case of DSS because NR is forced to share the same LT grid. So what happens, friends? So you have got the control channels which are running here, which has to be the control channel of LT, because LT will always be live whether LT is there or not. These control channels are going to remain all the time. So they will consume a lot of overhead, and the NR is going to share the same grid. So this is NR and this is LT, right? So they are going to, this is time division multiplexing. So what you're doing is you are already doing time division multiplexing, then you are packing the LT and the NR symbols alternate to each other. So if you see here that this is how it will look, right? So you will have, this is the overall grid, this is the symbol sizes, this is the subcarrier size of 15 kilohertz. And what you are doing is you have got an LT frame, you have got the signaling frame, then you have got the LT frame, then you have got the NR frame, then you got the not frame. These are all symbols. And then you have got this, the signaling symbol, then you have got the LT symbol, then you have the NR signal. Now, this NR symbol could have been shorter if you had been able to increase the subcarrier size. But you can't, because you have to use the same grid because you are tied to LT. And that is the reason why, friends, we have this loss of efficiency, overhead. Both signaling as well as NR not able to leverage the higher subcarrier spacing of 30 kilohertz, which we saw here, right? You see this one, 30 kilohertz. So if you have increased the subcarrier spacing, then your symbol duration, what will happen to the symbol duration? The symbol durations are going to decrease and you will be able to transmit the data at higher speed. That's why, friends, DSS is not useful in 700 megahertz to make a migration from 4G to 5G, because you can't uproot your 4 equipment. So in net, what I am trying to tell you, friend, BSNL is completely screwed up. They neither can use 900 megahertz to deploy 5G, nor they can use 700 megahertz to deploy 5G using DSS technology, because DSS is going to create this problem which I have showed you, that your LT is going to be your 5G is going to be restricted to use the same frame structure as OFDMA grid structure which LT is using, and therefore it will not be able to leverage any of its capability. It is as good as LT, and with a loss of 15 to 25% of capacity. So what is the point then in using 700 megahertz? So all the equipment that is lying there, friends, which is 5G upgradable, it's actually useless. Whatever the minister is saying is of no value, because 700 megahertz you can't do even DSS, right? It's going to create a huge amount of problem. And 2100 megahertz you can't deploy 5G because it is not going to serve any purpose, because you need a low frequency band to do voice. So what is that BSNL is going to do, and how BSNL is going to migrate to 5G? I have no clue. You tell me, friends. And that's what I wanted to do in this video. I'm going to stop here because this video was a little technical. I wanted to explain to you this DSS concept, and therefore it has gone to 20 minutes. Otherwise, I would have liked to finish this in 15 minutes. Thanks for listening till the end, friends. I hope that you understood. I could not explain to you why it was 1 upon F. That part I am just leaving it. Because otherwise the video will just go beyond this, right? So let's stop here, friends. And then thanks for listening till the end. I'll come back with a new video and a new topic next time. Thank you very much, friends, for listening.